Let's work on evaluating this limit as x approaches 2. So when you're evaluating limits where x is approaching a specific value, what you always want to do is you want to begin by evaluating the given function at that value of x. So try to plug in that value where each one of the x's is in the original function. So it goes in those two places up in the numerator, and it's going to replace the x in x minus 2 in our denominator. From here, let's see if we can simplify. I think this works out to be 4 minus 12 plus 8 up in our numerator and 0 in the denominator. Continuing on, we end up with 0 over 0. So in this specific case, when you get to 0 over 0, we need to continue going. If it was any other case, you would kind of stop there and you'd be done with the problem. But in our case, we want to continue. It's actually not a bad thing to end up with 0 over 0, and you're going to find as you're working through, a lot of these end up in this same sense, all right? But that actually helps us out because we know that when we evaluated it, both the numerator and denominator at 2, we ended up getting 0. That means that we have a factor of x minus 2 in both the numerator and the denominator. You can already see it in the denominator, and we can work to do a little bit of factoring in our numerator so we can see it up there as well. So we know x minus 2 is one of our factors. To get the x squared, we know it's going to be x times x. And to get the 8, well, we know we have a 2 times 4 is going to give us that 8 for our constant at the end. We just have to be careful about the sign. All right, I think this is going to be a negative 2 times negative 4 is going to make that positive 8 at the end. And also negative 2 plus negative 4 makes the negative 6 for our coefficient on the middle term. From here, notice that we can reduce this down. We have a factor of x minus 2 in the numerator and a factor of x minus 2 in the denominator. So that'll reduce, and we're allowed to do that as we're doing these limits. So what we want to do is we are down to just x minus 4 remaining. To finish this up, we're again going to evaluate by replacing the x with the 2. So 2 minus 4, and we're going to get to negative 2 as our final solution, and that's the limit completely evaluated. So I hope this helps out as you're working on evaluating limits. Remember to always begin by substituting in the value, and if you get to 0 over 0, keep going and be looking for that factor that you know is going to be there.